Good day, everyone. Thanks for joining today's class. Today, we'll be carrying out calculations on the efficiency of a machine to determine the work done by a person carrying out the works on the machine. Okay, you can see calculation on the efficiency of a machine to determine the work done by a person using the machine. Let me explain the process of carrying out the work in this type of particular question. You have a pulley, you have a rope attached to the load. This is the human being trying to pull the load up to a particular height. This is the load, that's 200 kilogram, but you have to convert it to weight by saying 200 times 10, which is 2000 Newton. Newton. Now, this is the height at which the load move up 3 meters. Okay. Now, we want to see the work input by this person. This is the it apply efforts in pulling this load. We want to see the efforts. Okay, we want to see the work input. Work input. The work input is effort times distance moved by the effort. That's the work input. We want to see the work input at which the individual pull the rope, okay, so that the load will move up to a particular height where you want to take it to. Now let's write down the parameters. The efficiency, let's use capital E to represent the efficiency. That's 80%. Determine the work done by a person using this machine. That is the work input. This is the work the individual puts into the pulling of the rope. That's the work input. If not, the load will not move up. The work output will be load times distance moved by the load. Okay, that's the work output. As we have work inputs, that's what we are looking for because we don't know it. Work inputs, work subscript IN, question mark, the load, so that you are giving as 200 kilogram. But since you are told that your G is being given as 10 meter per second squared, you convert your load to Newton. Your load, that's the weight. The formula for weight is mg. Take note. And the load now will now be 200, which is the mass, times addition due to gravity, which is 10, which is now 2000 Newton. Now be 2000 Newton. 2000 Newton. The unit of load is Newton. Okay, and the height h is 3 meters. Now let's go back to the formula. We're having efficiency equals work output over work input times 100%. Times 100%. Don't forget that your efficiency is 80%. That's 80 over 100 equals work output. Work output is load times distance moved by the load over work input. And the moment you write 80 over 100, no need of put 100 at this other side. Okay? But when you put 80, ordinary 80 here, you can now put 100 over 1 at this other side, 100 over 1. Okay? Please take note. Some students make mistake after putting 80 over 100. You still put 100 at this other side. Please take note. Now, you have it to be equals to, what's your load? Load is 2000. 2000 times 3 divided by work input. Now, 80 over 100 equals 2000 times 3 divided by work input. We cross multiply. Now 80 work multiplied by work input equals to 2000 times 3 times 100. Divide both sides. Divide both sides by 80. When you do that, you're having 80 multiplied by work input. This when you're writing work input, let your W so be very big and small in work input divided by 80 equals to 2000 times 3 times 100 divided by 80. 80 cancel 80, 0 cancel 0, 2 in 8, 4, 2 in 10, 5, 2 in 4, 2, 2 in 20, 10, bring the remaining 2, 1, 0, 0 up, okay, 2 here 1, 2 in 10, 5, bring the 0, 0 up, you're left with work input to be equals to 500 times 3 times 5. Now let's do the multiplication. 500 times 3, 3 times 0 is 0, 3 times 0 is 0, 3 times 5, 15. Now 1500 times 5. 5 times 0 is 0, 5 times 0 is 0, 5 times 5, 25. Put 5 down, carry 2. 5 times 1, 5 plus 2, that's 7. That's work input. Work input equals 7,500 joules. That's the work input, which is the work done by a person using this machine to raise a load. Work input, that is the work you put into the machine in carrying out the work. That's the work input. That's effort times distance moved by the effort. But we are not giving efforts and also distance in the question. Just write it as work input to represent effort times distance moved by the effort. That's why I wrote it as work input. And don't make mistake of taking work input to the numerator. Work input always be at the denominator, while work output is always at the numerator. Take note. And also when you write 80 over 100 as your 80%, don't put 100 over 1 at the right hand side. Don't multiply 100 with working output over work input. When you write ordinary 80, you can now put 100. You can multiply work output over work input times 100. Is that okay? You either pick any of the two, but don't write 80 over 100 and put times 100 at the right hand side at the same time. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates, and also don't forget to leave your question in the comment section. Thanks for watching. See you in the next class. Have a blessed day.